Good afternoon. Hippo offline and runtime formal verification for autonomous systems. The proposed approach relies on Fiacre, a formal language developed by the Vertex group at LAS, which can be used to describe processes with automata, ports, time and guarded transition, and variables. As shown on the drawing, instances of these processes can be connected through their ports and composed to make components. The resulting synthesized time transition system formal model can be checked offline with properties similar to linear temporal logic, but using event ports and tasks linked to C code, it can also be used at runtime with the Hippo engine. Moreover, in the robotics and interaction team at LAS, most of our autonomous robots are programmed with a number of components which can share data with ports in green and are in charge of the various functionality of the robot. Here, a quadcopter with its 5 functional components, most of them running at 1 kHz. In particular, POM for position manager, NHC for flight control, or rotorcraft handling the sensor and effector on board the drone. All these components share the same internal organization and algorithm shown on the right. These include a control task, an internal data structure, some ports in and out for the sharing data between components, some periodic execution tasks, activity services with their own automata, and codel in C attached to the state of these automata whose execution returns the next state. As a result, all the components are defined with their own specification as shown on the left, with the component specification and the components codel and codel works execution time. Using a template mechanism, all these specifications are automatically translated to the Fiacre model representing the internal organization and algorithm of the component, 37,000 lines of Fiacre in this drone example. And this formal model can then be used offline with the TINA model checker or online with the Hippo engine linked with the C code of the automata to run the real experiment. As a result, for a given hardware, we can check temporal properties offline, such as schedulability of the various tasks running on the drone, the exclusion of 2 incompatible activities, or the maximum time between 2 events. The same model can be used with Hippo to run the real experiment and check for generate temporal properties. But we can also add to this 37,000 lines of automatically generated Fiacre code some monitoring code, as you see on the right of the screen, to enforce safety specification. For this particular example, to perform an emergency landing when the drone has lost its position for more than 200 milliseconds. So the video shows a run with Hippo, which is executing this 37,000 line of Fiacre model at 10 kHz, linked with the experiment codels. Here, as you can see in the bottom right pane, we inject a fault to delay the position update by 200 milliseconds. Above, on the top pane with the Fiacre model traces, we can see that the Fiacre monitor presented on the previous slide has detected the delay and triggers the emergency landing. Overall, such formal approach offline and online could participate to the certification of autonomous systems. Thank you.